Okay. Can you hear my cat? Alright, so we are doing the velocity and displacement and distance type problem here. Now, let's do displacement first, of course. What is displacement? We've seen before that the you can find an antiderivative of velocity to get displacement. So you can think of this as like, well, let's let v of t be our small f. So we'll say f of t is our velocity. So capital F is going to be our displacement function. Okay, so here we want, for displacement, we want the final displacement minus the initial displacement to find the total displacement here. Okay, so according to our arrangement here, we can have f of 4 minus f of 1. And now we use FTC2. We remember this is the definite integral from 1 to 4 of f of x. Well, let's go t. F of t dt. So this is FTC2 here. And we can calculate this in a relatively straightforward fashion. If I have my function, what is my function? T squared minus t minus 6 dt. So displacement is the final position minus the initial position, and we're able to use FTC2 to sort this out. Oh la la. So I get t cubed over 3 minus t squared over 2 minus 6t. So I'm using this formula over and over and over again. This guy. And I'm evaluating from 1 to 4. So plugging in 4, I get a mess, but let's just work it out. Minus, plug in the 1, you get 1 over 3. Minus 1 over 2 minus 6. Now what I like to do is I like to put the buddies together. The buddies. This is a buddy. This is a buddy. Why are they buddies? Because they have the same denominators. This can be useful sometimes. So I got 64 over 3 minus 1 over 3 giving me 63 over 3. Now I got negative 16 over 2 minus 1 over 2. So that's going to be plus 1 over 2, giving me 15 over 2. Then I got negative 24 minus 6, so negative 24 plus 6 minus 18. So it's this. So it's 21 minus 15 over 2 minus 18. So just slowly working this down. 21 minus 18 is 3 minus 15 over 2. That's not a 2. That's a 2. So I get 6 minus 15 over 2, negative 9 over 2. Oh, my displacement is negative. I'm going backwards. That's okay. That's okay for displacement. It's not going to be okay for distance, though. What is happening here? So when I do number 2, where I'm interested in the total distance traveled here, okay, remember displacement is a vector, and distance is a scalar, or just a value without a direction. So distance traveled should be positive, so I have to be more careful here. And let's see how I can do so. So I'm going to go back to my function, and I need to find out when it's 0. So S of t is t squared minus t minus 6, if I'm not mistaken. Yep. Oh, it's not S. That is not S. It should be the velocity here. Sorry. So I factor this. I get t minus 3, t plus 2. So v is 0 when t equals 3. So if I drew the picture here, 1, 2, 3, 4. So my velocity function goes through here. And let's see, just quickly doing a test point, I can see that it is going to be, if I plug in, say, the number 1 here, I'm going to get a negative number. So it's doing something like this, I reckon. It's a parabola. I'm not really sure exactly what it looks like. I don't really care. I just want to get a rough idea of what's happening here. So at least in my diagram, you can see this area down here is outweighing the area up here. So for displacement, we did negative a1 plus a2. For distance traveled, we want to do a1 plus a2. Okay, when you're talking about distance traveled, I may have a negative velocity here, but I don't want to have this subtraction happening here. Okay, if I go forwards or go backwards, I'm still covering distance, so I want that to be counted properly. Okay, so when I did displacement, I was able to do that. This is what my integral here was able to calculate. But for us, we're not going to be able to do that. We're going to have to do, we can do it with integrals, but we have to be more careful. We have to do absolute value, first of all. We'll do the absolute value of velocity. And based on our diagram, we can break our integral at 3. So we can go 1 to 3, and then another integral from 3 to 4. So I'll leave the absolute values in there for now. Okay, from 1 to 3, we can see that the velocity is negative. So absolute value is going to put a minus in front. And then from 3 to 4, my velocity is positive. So absolute value will do nothing. Okay, now we can work this out. this is the integral of negative t squared minus t minus 6. So this is tedious, but if I expect you to do it, then I should probably do it too, right? At least sometimes. Okay, it's best with these calculations to just be careful, take your time, don't try to do too many steps at once. It's going to involve a lot of writing, but hopefully fewer mistakes. And if you do make a mistake, it will be easier to find your mistake if you do lots of baby steps. Okay. Oh, this is going to be rough. Oh well. What do I get? I get negative t cubed over 3 plus t squared over 2 plus 6t from 1 to 3. Then I get t cubed over 3 minus t squared over 2 minus 6t from 3 to 4. Working this out. Minus 27 over 3 plus 9 over 2. Be careful, be careful, be careful. Mistakes here will be painful. Plus 6. Okay, so I did my FTC2 for that guy. And now I'll do the other guy. I will get 4 cubed over 3. Not 4 cubed, 64. 64, 64. 16 over 2 minus 24. Okay, I'm going to take a second just to have a look at this before I start doing common denominators. Just take a quick look at it just to double check that I'm not making any glaring mistake here. Okay, I don't see anything. Okay, now just do baby steps here. Minus 9 plus 9 over 2 plus 18 minus, oh no. Nothing to accomplish there. I'm really not getting anything done on this step, am I? Oh well. Oh, here we go. Minus 8, minus 24, minus 9, minus over 2, minus 18. 9 over 2 plus 9, doing lots of writing, but not a lot of calculating. And that's okay. Okay, so I have some buddies here, which I'll put together. I got tick my denominator 2, denominator 2, denominator 2, and I got denominator 3, denominator 3, and then I also have the constants So my constants will be 9 minus 6. 9 minus 6 plus 9. 9 minus 6 plus 9. Oh, and there's a 32 in there. 9 minus 6 plus 9. 9 minus 6. Let's put the minus 32 first. Minus 32 plus 9. Then I got 9 over 2 minus 1 over 2 plus 9 over 2. And finally, in red, I have the denominator 3. 1 over 3 plus 64 over 3. So there's plus signs in between these. All right. So I get 18 minus 38 minus 20. Here I get 18 over 2 minus 1 over 2 is 17 over 2. This is completely wrong. No, it's not. Wait. Did I do absolute value? Absolute value. Oh, I did absolute value. Yes, I did. Sorry. Sorry, I got a bit of a cold here. Having trouble concentrating. Where was I? So I thought momentarily I had a mistake, but I think I'm okay. And then plus 65 over 3. Okay, I'm going to go denominator 6. This is minus 120 over 6 plus 51 over 6 plus 130 over 6. 181 minus 120 over 6. 61 over 6 meters. Whew. Okay. So, quick recap. Here we go. So displacement is this kind of net area here, signed area. But for distance, you want to do strictly positive areas and add them up. So I use the absolute value here. That requires that I break my integral up into two pieces. One of them gets a negative sign due to the absolute value. One does not. And then I have this awful thing to calculate, which somehow I managed to do and get the correct answer. When you're working this out, we're not going to make you do anything quite so awful on an assessment, but in your practice problems, just take your time.